Looks like that's working. YouTube is got excellent connection. Okay, cool. Um, where's it getting? Yeah, we can try that. Okay. YouTube looks like it are up and running. Cool. So we actually have some viewers on Twitch. Okay. Let's see how this goes. So, welcome to session 2 of how do you do a Vitis Extensible platform. So let's talk about what we did last time. Our little overview. We have these two boards, the KV260 starter kit or the Kira. We have the ZCU 104, which is probably the next best affordable. I guess we could do the Ultra 96. The Avnet ZU1 board's coming out. I should hope to get that by the end of the year. We can probably do it for that board. So the Vitis Extensible platform allows us to, using the Vitis V++ linker, allows us to integrate RTL, Vitis HLS, and for the Versal AI compiler kernels into our design. So we built a design and we put it into our extensible platform. We added a HLS function right here, and we were able to have it link into the design, and it built a block diagram, which is really cool. So Vivado did this. Vivado added the interrupt controller, added this interconnect, added this these interfaces right here for this HLS core. So the HLS core uses axis control for control and status, and then 2 axis master ports to be able to read and write from memory. And if we go to address editor, we can see the control is at this address, and that the HLS core has full access to the DDR memory. So how do we write bare metal code for this device? It's actually relatively easy. We take this base address right here, and we go over to our HLS core right here. And we have, so in the hardware build, the kernel, IP drivers, kernel source, we have this hardware H file. This is like the bit control for your driver. You're like, how do we do driver for this? So we have 8 bits of control right here. We have our global interrupts that we can set up, status registers, and then we have our input values. So in This is our 64-bit address for in. This is our, so if we go back to this, right? We have a pointer for in1, pointer for in2, pointer for out2, and size. And we basically put the 64-bit address for the two inputs, the 64-bit address for the output, the size, and then we start. And that's how we could operate this core. I don't have it set up right now where we could do that, but maybe next time we can actually get something working in this system. So, let's try adding a new kernel. I'm curious. So file, I want to add a hardware kernel. Next. Yes, we're going to add to this board. It's going to be part of this system. And it's going to be AOC day 1 part 1. So in here, we're going to import a single file. So we're going to go to AOC is advent of code, in case anyone thought it was, didn't know what it was. And we're going to select this folder, and we're going to do part 1, and we're going to add it. So now we have this HLS core. And now we're going to add that function. Now we're going to try to build that project. This is how we can do HLS. This is so nice, so much faster than other HLS systems I've done before. And you potentially could just, you still could edit the hardware before and after you create the extensive platform. So this is using, did it actually? Cool, it built. So let's look at the HDL for this real quick. This is actually using, oh, it didn't open here. Okay, it's actually using Axis Stream. So what we're going to do is now we're going to go to the hardware link project right here, and we have this. So it's now out of date. So we're going to close. Let's go ahead and close this project because it's going to regenerate it. So now we're going to build this. The weird thing, so like if we go here, right? These are like the main variables, like the in-stream and out-stream. But there's no Axis stream. I want to see if it breaks. Does it automatically add a DMA core, or does it work on its own? So yeah, we're just going to build hardware container. I also need to figure out how I turn off the SD card. Has to be. Ooh, open Vitis analysis. Ooh, we'll do that in a second. Okay, what is it? Okay, connectivity failed. We could no stream resources found. Okay, so let's make a new extensible platform. So we're gonna go back here. We're going to add a DMA port. Let me make sure I know how wide these were. 32-bit. Cool, we're good there. So we're going to open here and we're going to add a DMA port. So let's add DMA. We're going to do direct memory access. And this is really complicated. We're going to say we're going to keep it simple. Keep it simple. 32 channels. That's all good. Address width needs to be 64. Okay, now we're running connection automation. Yeah. So how are we gonna? We're gonna have to connect it to this guy. What's the best way? I guess we're gonna have to just do one of those. Yeah, we'll just do one. I think it's gonna be upset though that I guess we'll have to play around with it otherwise. Okay. Run connection automation. Cool, cool, cool. Now we're going to go to platform setup. We're going to go to Axis Stream port. We're going to call this MM2S and S2 to MM. Okay. Now we got to go over here, validate system. Okay, clocks have different frequency. Okay, so we go here. Which clock is that? Oh, it's supposed to be on the 200. Um, pin, and where's our DMA core? DMA core. Pin, pin. This is all running off 200. Okay. Oh, okay. Grab that, bring that over here. All on the 200. Okay, refresh, validate. Okay, that's fine. That's okay. Now we're gonna generate global, and then we're gonna export. Mhm. Anyone have anything to talk about? Any questions? Any news? There was the satellite that hit an asteroid. It's kind of fun. Ooh, that's a cool one. Okay, that's fine. They're all good. Let's export the platform. We're in hardware emulation, pre-synthesis, hardware 001, KVT60. Yes. Yeah. Next. Okay, finish. Now let's go through the whole process again to add a hardware kernel to platform. Okay, we're gonna create a new workshop. It's gonna be, and we're gonna see if connects the DMA stream ports, and then I guess we can try to get it to work. I would have to get the DMA to work. Man, it's been a while since I had to read. We would have to read through documentation to get the DMA core to work. But it would be possible. I would have to plug in hardware. I mean, if it works, it works. But let's see if we can do it from scratch. We're gonna call this KV260, and we'll call it the BSB. Port support. Let's browse. The we're going to send KV that one. Oh, do we have a lawsuit with Qualcomm? What is the ARM Holding has filed suit against tech giant Qualcomm and its NVIDIA subsidiary breach of licensing and trademark infringement? Wow. Wow, I have not heard about that, but I need to go read about that afterwards. That does look interesting. Okay, I'm gonna standalone, stick that on the PS. Cool. Let's see how fast we can make a HLS DMA system. Always finding annoying the other method to add HLS cores. This is actually pretty nice. We could put switch. That'd be funny. We should try that. I'm gonna try that after. We'll put a giant axis switch, axis stream switch, and see what that does. Okay, everything's good, so we're gonna go ahead and build that. We're gonna do an application of hello world. Then we're gonna do a kernel. Then the link. Then I have to figure out how to use the linker. That could be fun. Oh, it'd be great to learn how to use the axis switch interconnect. We should just pop down and interconnect. Okay, so finish. Now we're gonna do a new application project. We're gonna call this yeah. Next. This is for our whole project. This is gonna have the hardware link and the kernel. And we're gonna start with a base project name here. top. We'll just call it top. Or just call it the hello. Hello. Yes. Yes. What do you think of the Qualcomm and ARM loss? Curious. Okay, we have the hello system. Go ahead and build that. Shouldn't take too long. Cool. Now, if we're going to add a hardware kernel to the system, to the hello system, this kernel is going to be AOC day one, part one. Yeah, finish. Okay, so we have the link and we have the part. Let's go ahead and import source. AOC day one, sources, source. Oh, wrong one. HLS one, source, select, part one. And the like a simple increment counter. I gotta do this for AOS Advent code. Oh, that's gonna be so hard to get all that done in time. We gotta get it working with the pink. I guess we could build it and transport it to the pink. Yeah, we'll have to get the pink running. We'll have to do some prep and tests. End of November, we're gonna have to practice. Okay, so we hit the project, tell it to function, boom. Now we're going to build that. Oh no. I don't want software. We want hardware. Go. Build. Oh, and we want to export the XSA. Hit options. Dipsto debug. Oh, interesting. Line close. Oh, I finished. Okay, let's run the big one then. I need to figure out how we get rid of the SD card portion here. I did not see it. Is it in the platform? See any SD card there. Hello system, platform, manage. Nope. Okay, we have different things there. I don't know how we would go about. Oh, what we have here. Okay. Okay, so we have a port. And so we're gonna learn how to connect it manually. So it looks like stream, we're gonna have to connect manually. So we're going to have a new folder here. Folder name is going to be config. Okay, so where we're going to go here is going to bring up the Vitis tutorials on GitHub. We're going to go to AI development feature tutorial A to Z, and right here. There's this connectivity right here. and we're going to need to create a connectd config file. So we're going to go new file. We're going to call it connect. What did they say? Connect activity.config. And we're going to go here, but so we got to go to the names. So we go back here, right? We have MMM2S. That's the master port. We're going to do MM2S here, S2MM here. But so we're gonna go, we have this day, an in stream. Oh, we just have an in stream. That's all. Okay, so in stream. Right? That's all we need. Now we're gonna go to edit options, and we're going to apply. So um we want to add that. Where did they want us to add this script? Selecting add it to the simple application hardware link folder. Okay, so I think what we have to do is then config slash apply, and close. So now we're going to build. Run link failed. Invalid slave. What do we want? We want the MM2. Yes. So you don't like that. So help me figure this out. Streams. SCTech applied with the invalid slave kernel interface. Okay, help me with this. One part one dot in stream. That what we see here. We want the MM2S. Okay. Dude, we're so close. Figure it out. referenced it correctly. AI engine iGraph. Okay. That's the direction I expect. You have any way to test it? Connectivity, day one, part one, link summary, help, link. Okay. Yeah, that's interesting. Is there any way to manually link it? I don't think so. Okay. Oh, it's the underscore one. We need the underscore one because it's an instance of it. So back to connectivity. Need an underscore one here. We couldn't find the tag. Okay, build. Let's see. Oh, it connected. Yes. Okay, cool. Now it's going to build it, and we can look at the project afterwards. So we're gonna go do something fun while it builds, because it's gonna take a while and use all my processing power. So we're gonna say block design. We're gonna save this one as cancel. We wanted file project save as is what I'm trying to do. Got the KV 260, right, 001. We're going to save it again, do the 2, and we're going to try using the axis stream interconnect. Project new. Or no, save as. I'm going to call this one KV260.002. Surprised me. Oh, okay. I was not happy about that. M01 axis already connected to the oh, we screwed up things. Okay, we're gonna use the axis interconnect now. So we're gonna unclick these axis port. So not even here. Okay, yeah, those weren't there. I wonder if I think it just was an artifact from the previous one. Yeah. Okay, cool. So let's show you what I'm gonna do. We're going to add my favorite IP, the stream interconnect, one I have never got to use. So it's gonna be a 200 one. Boom. So we're going to have this. What are you talking about? This is an Axie RTO. What is this? An Axie RTO. What do you not like about it? Yeah. Ooh. Should be working. Are you not working? Full register routing would be nice. Yeah. The auto connect is not working. That is weird. Okay. Is it lacking T keep? I guess I could use the switch. Weird that this is not working. It's simply because we don't have the T key. I don't have a way to turn off the T keep. Enable single. Okay, that's not worth it. I wanted to use this guy. Come on. That's disappointing. What do you mean? Let's see. We can just double click this. Oh, that's fun. It's the right type. Annoying. Supposed to connect automatically. That finally works. Sheesh. Okay. And I guess we'll just hold it there. Okay. Now it magically works. Who did that? Okay, cool. So we're gonna go here. We're gonna go, we'll just say 4 and 4 and hit OK. Now we have this interconnect, which does a lot of really cool things. It allows you to put packet headers to tell it where it's going. It's really cool. So, but let's go up here. The M2 right here, this one is no longer valid, right? So, no, we still have it. We didn't actually get rid of it. Okay, actually stream port. There are no stream port interfaces. Yes, there are. You don't recognize these as Stream? Okay, cool. We will use a different IP then. The Actually Stream for Switch. We will use control registering as well. And we'll have 4 and 4. Connectivity. All connected to each other. There we have a switch. Okay, so now this is attached to 2. I want to see if the 2 disappears. Wait, 2 did disappear. That's good. I'm gonna have to. I'm really curious real quick. I'm gonna delete these, get these open, see if this system is stupid. Maybe I have to like roll around, validate. Oh, okay. Those didn't come back. That's weird. I made them open. Oh, maybe I have to go here and be like, hey, there's only one. Right, right, right. Maybe if we do that. Okay. Now we get rid of the 2. Okay, we gotta make sure we remove it before we add it. Actually stream port. Okay. That works out. Okay. Now let's go ahead. Went to that one properly. And now, since this is okay, we want to connect that one there, there. And we want to validate. A clock versus switch. Right there. Reset. Validate. Okay. Not even complaining about anything. Oh, we're gonna say which. How did connectivity work in the tutorial? I want to say switch dot that's 0, 1. Switch dot F0. Okay. Okay. And we don't have that one, but I'll make sure. I think we should be fine. But yells at us, we'll fix it real quick. Yeah, that should be fine. We want to add any stream ports on that? Nah, I think we're good. That's basically what I would want. I mean, in the end, we might put some on that. So we can have the switch. Okay, now let's generate this, get it global. Okay. Any questions, discussion ideas, why we build? I want to be able to stream in 4K. YouTube lets you stream in 4K? Hmm. Be interesting. Okay, cool. I don't know why that button isn't highlighted, but oh well. Okay, so now we know how to do this. Let's yeah, set it up. Okay, so which workspace? Files there. Sure. Okay, platform project. Maybe 60. Browse. I kind of wish I went to a different location every time. So I wonder if yeah, I guess you just take the XSA file and software off there. Yeah, I'm not really sure. Hmm. Okay. Guess we could do a packet base. Right. Yeah, I'm not sure. Um, yeah, let's go ahead and build. Then we'll add a hardware kernel and try to get up and running. Okay. We're done. Now we're gonna do a new hardware kernel. Create a new project. We're gonna call it the Hello project. Or well, this kernel is called the AOC E1P1. I should just call it that way. called the hello system. Finish. Okay. A way to select that. And just say hardware across the board. Yep. Okay. Let's import that source. Curious, is it just there? Day one, HLS one, R1. Then we're going to here add that. Then we're gonna build it. Right, that's building. We're going to put a new file here. Connectivity. Big. Very well. Oh, wait. Okay, cool. We're gonna back to this tutorial. And we're gonna do what we did in our stream port switch. Master port, right? That is on these sides. So we're gonna go switch one, day one, part 4_1, in underscore stream, I believe. But double check. That's the connectivity. Got that good. Compute units. Oh, cool. Yeah, we're gonna do it. I want 2 of these because I'm curious now. Okay, you guys ready? I'm scared. Let's see it fail. Oh, my bad. We missed an important part. Okay. We're supposed to do, what is it? Config? What's the command? Config. Dot slash connectivity.config. Apply close. My bad. I'm gonna have to complain about the Axis stream interconnect not working. Which didn't like that. Oh. Okay. Didn't like the metadata for that. If that's the case, I think we just used the wrong name. So, oh, no, that's not what I want to do. I think we just do that. It should be happy. I guess we just broke it with the name. So, trying to do underscore BS. If that works. If not, we're gonna have to rename these guys. Do not use dots. That would work. But let's go look at it, right? Let's go see what it did. Let's show you how you decode an exe file real quick. So we go to file location and we go, hey, I want a copy of that. Yeah, sure. We're going to rename it .zip. Yes, I know it's beautiful zip file. Boom. Okay. Pop wrapper. Is it going to be, it's the XML. Oh, JSON. SP tag right here. I mean, that's what we put. Did not like that. Let's go back to the name. Let's try that if it's happy. Okay, sure. Let's try this. If this doesn't work, we may have to edit the JSON there. Where is that JSON located? Hardware? Yeah. You don't really bring it out. Ah. Three segment tabs are range tags. Okay. Very well. Um, I don't know why it just doesn't like that. Okay, so we're just gonna call this what did we do to the ports? It just you know what? We're just not gonna have anything. Yeah. Um, okay, now I'll try this one again. Go ahead and get a new workshop. Finding all the bugs by trying to do stupid things. Okay, so that SP tag didn't work. Hardware, pre-synthesis. Two. 2. Okay, let's get the AG260 platform going. Then we can investigate the SF tag that I decided to put on there. Okay, while we're here, folder. Okay. So this JSON. What tags did we didn't have? Okay, built. Go for it. So yeah, it's going to be the full name this time. And we'll try it again. Try one interface, I guess. And yeah. Okay, cool. New hardware kernel. Next. Sure. Finish. Oh, it's down here this time. So we're gonna hit temp project. We're gonna say we're gonna aim for hardware. Now everything should be hardware. So if we're gonna add, import that source. One function. Nope. Function. Have one of those. Going to import source from our previous project. Folder. Okay. Um, Edit options. Big. Activity.config. Apply and close. Build. You gotta build the other way. We're building the kernel. Okay, hopefully this works. Otherwise, you know, I didn't have to go back to just trying to do DMA. So let's go back to which that works. Documentation, product guide. I want to know if you can have like um uh, which was it's P885. We'll just go to PG85. I want PG085. Finally. Go. Supports multiple arbitration. Okay, the switch does do round robin. These streams switch. Product specification. XE stream switch. Okay, each master interface is assigned a base and high is used to generate decode. Each slave interface decodes the country based on the valid. Okay, so if we turn this off, we have routing. Oh, okay, interesting. Then these guys have a T destination. They don't. Interesting. Okay, yeah, we should try that. Ah, I was happy with that. Finally. Okay, cool. What can we do for the next 25 minutes? Because it's probably going to take that long. We might be able just to open the project it's running and look at it. So let's go file. Go open a project. Let me show you how nasty this path is. Uh-oh. So we can't stream and perform Vivado on the same system. It doesn't work out well. Okay, we should be able to look at this project while it's building. Okay, cool. So it's running the block diagram, so it can actually open it while it's building. It's cool. Okay, now show me what you got. So we have the in-stream port coming from there, and we have the control, and it worked. This is kind of redundant, isn't it? And nothing's really running off of that. Okay, we can do it. Okay, the only issue, these don't have the destination. Huh. Okay. So I guess we let that run for a few minutes. I want to read about the AxiStream interconnect. Broadcaster. What is the interconnect? Okay, so we can do optional. Okay, let's go read about that again. A little bit confused when you said the two routing options are TDES. Okay, TDES routing uses RTL configured before to continue routing. Each master interface is assigned a base I pair that decode cable. Each slave interface decodes the income based on the validator and routes a request to an arbiter of one of the master interfaces. The arbiter responds with a grant, and the slave interface uses the transfer. Arbitration can be performed at the transfer level or at the transaction level. No. Optional is available. Terminances can help deadlock systems. Okay. This one register for each of the match to control each is once the register has been broken, commit transfers the program values from the register and if it's switched held in reset. Only one path between is attempting to map. R to prevent for each slave interface. Okay, interesting. Yep. The stream switch. Okay. Yeah, I wish there was like a little packet information. Guess we could create our own packet system. Yeah. Okay. Interesting. We are still having issues with about it running in the background. Yeah, I guess we'll just watch the log then. Okay. So we have the switch. That's useful. But how much does the switch resource wise? That's pretty small, in all honesty, but it's probably simplified it because there's only one way. Oh, I can control it. So let's open the synthesized design. I'm curious how much space it takes. Okay, yeah. So we have all these interfaces working. Makes HLS easier. Maybe we should try some naive approaches to um, HLS. See what happens. Yeah, we should try that with AOC to see if we can play around with the device. Okay, report utilization. A pretty big device. There, cool. So I assume, yeah, the Smart Connect would be the biggest. Okay, yeah, that's actually interesting. What can we do with this? We want to do AI engines. I don't know. I kind of want to put this to the side because this I all understand pretty well. We could try to get one working. I think we should just aim it for Advent of code. Um, I do have a question. If we go back to looks like it's running in the background regardless of what I want to do with it. It must be doing its own runs. Okay, can we? Not a good way. This. Okay. Terminate. Cool. We hit 0. Ah, cool. So this should be easy. This is actually be really useful for like an advent of calendar or advent of code thing. I think we'll do it. Okay, so um there was that debug option right here. Okay. Let's go to the other one. The other one had I remember like we could like right click it and look at curious the what the Vitis analyzer. Is it coming back? Did we break it? Back. Where how did we get the analyzer working? Saw that. Um I guess we'll try this one. We have to go to the one we actually built things. No, analyzer. Okay, let's go back to the very first one, the one that built supposedly correctly. Thing options there. Oh, right here. Gear. Wherever there's a gearbox. Yeah, what if we open this Vitis? What comes up? Um. Oh, okay. Yeah, right here. Once you open the build, it's just file summary. Oh, is this the Vitis analyzer? Okay. So I guess our next step is to make a versatile design of an AI engine. Okay. I'll see when we can do that. So our next step is to get this working with Versal. I think we're gonna call it a day now. We'll be working on some TMR stuff tomorrow in the evening. I'll look at the Intel Deca. Try to get LEDs working on